Alright, so we're going to talk about the parent functions. Just a reminder, parent functions are the simplest form of each type of function that we talk about. It's the simplest or the most basic, right? There's no added numbers, there's no extra stuff, it's just as simple and clean as it could be. Alright, so we're going to be doing 10 of these. So today what we're going to do is we're just going to go over what's their name, what's their equation, what's their graph. Right? So these are our first ones. So we're going to start with linear. Linear is y equals x, right? That's the most basic. You could add numbers in there. You could do y equals 2x minus 5 or something like that. But y equals x is the most basic. For the graph, so I'm going to give you some key points that you need to know on it. It's going to go through the middle. Its slope is up 1 over 1. It's just going to keep doing that from there. That's linear. Linear is pretty easy. That's the simplest one. Quadratic is next. That's y equals x squared for quadratic. And the graph, the vertex is on 0, 0, and it's going to curve up on both sides, giving it a U shape. It's going to be 1, 2, 4 are key points there. These are going to help us when we do graphing later. That's quadratic. Square root function, that's y equals the square root of x. For this graph, we're going to start here at 0, 0. And we're going to go up and curve over that way. Make this a little more curvy. Because a square root can't be negative, we're not going to have anything on this side of the graph. It's all going to be positive. So this is all positive and this is all positive. So that's what we're going to have for square root. For cubed root, our equation is going to be y equals x cubed. Oh, sorry. That is not cubed root. This is cubed root. Cubed root of x. So for our graph here, because it's cubed root, it's going to do this. We got 1, 1. Similar to square root, but this time it is able to be negative. It's kind of going to go like that. That is cubed root. This is going to be, that's our first four. Got linear, quadratic, square root, cubed root. For our next set of 4 here, cubic, y equals x to the 3rd power. This graph, the middle is there. 1. It's kind of like cubed root, but we're going to turn it on its side a little bit. And it's going to go like that. It's cubic, y equals x cubed. Absolute value function, y equals absolute value of x. It's just a reminder, anything in the absolute values, these are called absolute value symbols. Anything in there turns positive. So when we do the graph of this one, remember y equals x without it was our linear function, did this, but that other half that was supposed to go this way, because this turns it positive, this graph is actually going to go up in the positive direction. Make a V shaped. Absolute value will always be a V shape. V for value. Good way to remember that one. We've got rational. Sometimes rational is called inverse, or sometimes it's called reciprocal. Thinks it's fancy because it has 3 names, but those are just 2 other names for rational. Rational is the most common of the names. That one is when your x is in the bottom of a fraction. Rational is kind of like ratio. Ratios are fractions. So rational is the fraction, where x is the denominator. This graph, this is the first one we have that have asymptotes. Alright, so remember asymptotes from algebra 2. It's a line the graph never crosses. Our last 4 functions all have asymptotes. But this one, our graph is gonna go 1, 1 here. It's kind of gonna go this way. It keeps getting bigger there, but this one, if I keep putting numbers under 1, the only way we can't make it 0 by putting a number under a 1. So it's never going to get to 0. But like if I put 1 over 1 million, that's a very, very small decimal. So it's going to get really, really close to that thing. So this asymptote is here. That's the asymptote, that red dotted line. In this case, it's x is equal to 0 is the asymptote. That's a rational function. Next, we have logarithmic. This is when we have y equals log of x. For our graph here, I'm going to do this. And again over here. Logarithmic, so we're never going to equal 0. We can't get them to be 0, so it's never going to touch either of these lines. The logarithmic actually have 2 asymptotes, one on x equals 0 and one on y equals 0. The logarithmic is going to look like this one. Right, so that's those 4. Got 2 more. Exponential growth and exponential decay. Exponential growth is y equals 2 to the power of x. This one, it's going to follow that 0 line here and then just shoot up really fast. Right, we can't get it to be 0, so our asymptote is going to be on this line, which is called y equals 0. That's our asymptote is here. This one is growth. You see how the line gets bigger as it's going over and then it's going up? It gets positive, so it's growing, right? Because everything's getting bigger. Decay is the same graph, but we flip it around. This one is y equals 1/2 x to the x. So it's still going to go through that 0, 1 point, but this time it's going to start up really high and then come down and then follow that 0 there. So the asymptote's still in the same place. But now, if you look at the graph, it's going down as we follow it because it's decay. Decay means decreasing. So that's the difference between those 2. Growth is going to grow, decay is going to decrease, go down. Alright, so that's our parent functions. Like I said, mostly right now what we're worried about is just being able to, if I give you a graph, you can tell me the name and the equation. If I give you the equation, you give me the name and the graph. If I give you the name, you can give me the equation and the graph. Alright, we need to know the equations and graphs for all the functions there. Oops. Alright, so you have an assignment to do.